So in this class, I will take up another problem on finding the extreme value of a given function, but some constraint is given here. So the problem runs like this: find the extreme value of z is equal to function of x1 comma x2 is equal to 2x1 x2. So that is the given function subjected to. So it is a constraint optimization subjected to. He has given one constraint here. The constraint is subjected to x1 square plus x2 square is equal to 1. So in the last lecture video, I have taken unconstrained optimization problem. So when constraint optimization problem is given, here also we have to find out the values of x1 and x2 for which this function z has got minimum and maximum values. Now in this case, in such a case, what we do is we are going to have one more function. We are going to derive one more function which is called as the Lagrangian function, that L is denoted by L. This L is equal to whatever z we have got here, that we have to take, that is 2x1 x2. In addition to that, we are going to take this, we are going to add this constraint also. The constraint is multiplied by a constant k into this is written by shifting this LHS terms to that side, that is 1 minus x1 square minus x2 square. So this is what we are going to take. So in the case of constraint optimization, single constraint optimization problem, so L is defined as whatever z is given 2x1 x2 plus some constant k into this is LHS is taken to RHS so that LHS becomes 0. So 1 minus of x1 square minus x2 square. So this becomes the function now. Now here also we are going to use the same necessary condition. The first condition is the first derivative of this L should be 0 with respect to x1. So dou L by dou x1 should be 0. If you differentiate this with respect to x1 by taking x2 as constant, you will be getting like this. It is 2x2 plus k into derivative of 1 is 0, derivative of minus 2x square x1 square is minus 2x1, and derivative of x2 square is 0. So this is what we are going to get. If you simplify this, what I can write here it is 2x2 minus 2kx1 is equal to 0, or you can cancel that 2 because it is common. You can write x2 is equal to k times x1. So this is what you are going to get by using the first necessary condition. Second necessary condition is dou L by dou x2 is equal to 0, which in turn you can write this as, if you differentiate this with respect to x2 by taking x1 as constant, it becomes 2x1 plus k into minus 2x2 is equal to 0. So that's what we are going to get. So this is equal to 0. So this if you simplify, once again it becomes 2x1 minus 2kx2 is equal to 0, or you can write this as x1 is equal to k into x2. So see, these two are the conditions we got. So these two conditions can be combined to one condition. So like this. So x2 can be written as, therefore x2 can be written as k times x1, where x1 is once again can be written as, so k times x1 can be written as k times x2, or you can write in other words by substituting you can get the value of x2 as k into x2 can be written as k into x1. So that means it is k square x1. So what we got here is k square x2. So what we got here is x2 is equal to k square x2, or you can written as this if you bring to that side, x2 minus k square x2 is equal to 0, or or x2 into 1 minus k square is equal to 0, or you can write x2 is equal to 0 or 1 minus k square is equal to 0, or you can write x2 is equal to 0 or k is equal to plus or minus 1. So this is what you are going to get. So we get the value of x2 as 0 and k as plus or minus 1. When x2 is 0, what is the corresponding value of x1? So x1, we know x1 is k into x2. So since x2 is 0, x1 also becomes 0. So when x2 is equal to 0, x1 also becomes 0. And since k is equal to plus or minus 1, so if you take this constraint kx1 square plus x2 square is equal to 1, this is the given constraint. If you substitute the values of x1 and x2 here, so what happens here is x1 is 0, x2 is also 0, but it is not equal to 1. So constraint is not satisfied. So given constraint is not satisfied for x1 0 and x2 0. Constraint is not satisfied. So therefore, among these two conditions, so this is not there. This we cannot take. Only chance is k can be taken as plus or minus 1. So therefore, k is equal to plus or minus 1. So this is the only condition we can get out of these two. So this x2 is equal to 0 cannot be taken because when x2 becomes 0, x1 also becomes 0, and the given constraint x1 square plus x2 square will not be equal to 1. It will be equal to 0 only. So therefore, constraint is not satisfied. Therefore, we can say either k is equal to 1 plus 1 or minus 1. Now let us see. First case I will take k is equal to plus 1. So if k is equal to plus 1, so then what happens to x1? So if k is equal to plus 1 and x1 is equal to, then x1 will be equal to, if you substitute here, x1 will be equal to k is plus 1 means 1 into x2 it becomes, that is x1 becomes equal to x2. x1 becomes equal to x2. So if you use this condition in the constraint, so we have x1 square plus x2 square is equal to 1 in the given constraint. If you use this here, if both are equal, then I can write this as x1 square plus x1 square is equal to 1, or 2x1 square is equal to 1, or x1 is equal to 1 by root 2 plus or minus. So plus or minus 1 by root, you can see. So x1 square is half. You will get x1 square as half that. So therefore, x1 will be 2. We will be having two values, plus or minus 1 by root 2. So that is the value. Root 2 is of course 1.414 something. Second case, if I take second case, in second case, k is equal to minus 1 I have to take. When k is minus 1, x1 is equal to minus x2. Because k is minus 1, x1 becomes minus x2. So this also, if I substitute there, the given constraint is x1 square plus x2 square is equal to 1. So if I take here x1 for x2 I can put minus x1. So 2x1 x1 square plus minus x1 whole square is equal to 1. You are going to get the same thing here. 2x1 square is equal to 1, or x1 square is equal to half, or x1 is equal to plus or minus 1 by root 2. Okay. So I can we can do another thing. So here I will put in the place of x1 as either this two of course we got the same. So in order to get the value of x2, what you can, therefore if you get the value of x1, x2 can be written as minus x1. Minus x1 is it goes reverse. So once again it becomes plus or minus only. So for this plus it becomes minus, for the minus it becomes plus 1 by root 2. So therefore we are going to get 4 points here. 4 points. So what are those 4 points? The first point is x1 is equal to plus 1 by root 2. x2 is also plus 1 by root 2. Second point is x1 is plus 1 by root 2. x2 is minus 1 by root 2. For the third point, x1 is minus 1 by root 2. x2 is 1 by root 2. For the fourth point, x1 is minus 1 by root 2. x2 is also minus 1 by root 2. So these are the 4 points we are going to get. Among this, of course, these are the extreme points we can say. Among this, you can have the minimum and maximum values. So you know that here, let us find out the minimum value and maximum value of z by taking these combinations. So there are 4 values of z we are going to get. So this is z. Given function is z is equal to 2x1 x2. Now let us evaluate this z value for these 4 sets of data. So for the first one, for the case of first this thing, the value of z becomes so 2x1 x2 means 2 into 1 by root 2 into 1 by root 2. So it becomes both the addition plus values. So this becomes 1. Root 2 into root 2 is 2. 2 and 2 will get cancelled. For the second case, z will be equal to 2 times x1 is positive but x2 is negative, minus 1 by root 2. Here we are going to get minus 1. Then for the third case, z is equal to 2 times minus 1 by root 2 into plus 1 by root 2. So which is nothing but minus 1 only. For the fourth one, z is equal to 2 into minus 1 by root 2 into minus 1 by root 2, which is equal to plus 1. That means among these 4 values, where we got the minimum value as minus 1. So this is the minimum value of z we got in 2 cases, whereas maximum value of z plus 1, so it is minus 1. Minimum value of z is minus 1, whereas maximum value of z is plus 1. Maximum value of z is plus 1. So this is how we can find out. So we got for this function, given function subjected to this constraint, the minimum value occurs at 2 points. One is at x1 is equal to 1 by root 2, x2 is equal to minus 1 by root 2. And another point is x1 is minus 1 by root 2, x2 is plus 1 by root 2. And maximum value also occurs at 2 points. One point is x1 is equal to 1 by root 2, x2 is equal to 1 by root 2. Another point is x1 is minus 1 by root 2, x2 is also minus 1 by root 2. So the extreme points means the values of x1 and x2, and the extreme values means they are the minimum and maximum values.